Okay, so I think we talked about how pilots navigate. So I guess flying is a relatively new subject. I mean, a couple hundred years, and that'd be old or new, depending on how you think about it. So back in about 1920s, they used to navigate by the use of the airmail carriers. They would use bonfires. They would navigate at night with bonfires placed on the ground to get to where they need to go. So during the day, they would put literally big concrete arrows on the ground, and that's how they'd figure out where they were going. So the evolution of that, what some people will call the most significant invention since the jet engine, what they call the VOR system. So the VOR system stands for, so it's very high frequency omnidirectional range. It's a radio navigational system, and it's a standard and primary navigational aid that pilots use for general and commercial aviation. The very high frequency part is limits the interference with weather and so on that aspect. So how it works, basically broken up into two parts. So there's a ground facility, just what looks like that, fairly simple, and you have your equipment in your airplane. So what this ground facility does is it transmits two signals. So one signal is an all-directional signal, which is master signal or reference signal. It goes just in all directions, so contracts and expands, omnidirectional, all directions. Second signal is a rotating signal, so it's a secondary signal that goes about 360 degrees, like a lighthouse. So what these do, so in your aircraft, VOR has a certain frequency that you type in your aircraft, and so that basically connects you to a VOR, so like a Bluetooth-ish. And so what these signals do is the equipment in your aircraft transmit these signals as it's called as a phase difference. It basically calculates, so it basically interprets it as a radial and gives you a radial. So what a radial is these two signals transmit or come together and basically emit 360 lines just in a circle. So like 360 degrees is what you call north, 090 is west, 180 or east, 180 is south, and 270 is west. So when you get the signal, it basically tells you which direction to fly to get to where you're going. So why is it important? So who, yes, this way, so who doesn't fly? Does anyone not fly? Like travel or anything like that? So not very many. So according to Air and Space Smithsonian, about 80%, or I guess of the airlines that are flying, they're basically 80% full on average. And last year they calculated about 3.5 billion people, which is about half of the world's population is using air for travel. So basically the main point of it is flying efficiently. So what these VORs do is they are designed to create airways and stuff like that for, like I said, general or commercial aviation pilots. And so if you notice when you're flying commercially, sometimes how it's basically a straight line the whole time, like occasionally a small turn or something like that. So those are typically when the airplane basically passes over a VOR, or it's changing to another VOR station, or intercepting into one of these airways. So it's basically all about efficiency and getting where you're going fast. And so the evolution of that coming is GPS systems. So GPS systems aren't like you use in your car. Like they're not, you just type in where you're going to go. And so if you're going from New York to California, you have to hit multiple of these VOR stations along the way. That's where the airways come in for the ease of use with that. So overall, VORs have proved to be a very reliable and accurate source of navigation, and with the incorporation of GPSs coming quicker in the near future, they'll provide with more efficient and quicker trips for people flying and traveling.